All right, we're going to talk about alternative research designs. Most people think about experiments or some sort of variation, a quasi-experiment, as the only way to do research. But I want to tell you there are a whole bunch of different ways to do it. The overarching thing that you need to remember is that whatever research question that you are asking should drive the method. In other words, the type of question you ask should lead you to a type of research design and a setup that will help best answer that question. And even though we can set up research in a variety of different ways, the best way is to focus on the question. All right, so we talked about experimental designs in a previous lecture. We've talked about quasi-experimental designs. We didn't really talk about non-experimental designs, but we'll talk about some of these that, today. There are correlational type research designs. There are descriptive type research designs. And we'll talk about some of these non-experimental types today. So when you think about every research design, I want you to think about what purpose does this design have? How do you set it up? And what are its strengths and weaknesses? Because each one will have a different set of those things. And then if somebody asked you, could you differentiate between these designs? Well, this one is strong in this and this one is strong in that. And hopefully between these two videos about experiments and quasi-experiments, you'll have a good sense of that. One of the more common things to think about is in an experiment, you have maybe a single independent variable that you're manipulating to try and explain to try and create a change in a dependent variable. So maybe we're, tweaking the amount of caffeine on, to try and see if it stimulates a certain type of response. Well, any design that includes more than one independent variable is actually called a factorial design. So factorial designs help us understand the relationship between multiple different independent variables on some dependent variable. So the other thing about factorial design is that they can look for interaction effects. So if we look at this first graph up here, this looks at the relationship between the amount of caffeine and response time. So amount of caffeine is on the x-axis and response time is on the y-axis. And as you increase the amount of caffeine, your response time goes down. Okay, cool. But also there's a secondary effect here that alcohol plays a role. So if you don't have any alcohol, your response time is faster than those who have consumed some sort of alcohol. Now, in this first model, the relationship between alcohol and response time is constant regardless of the amount of caffeine. That, in other words, the difference between response times between alcohol and non-alcohol is the same. But in a factorial design, you can also look for interaction effects, and one of those is here in this lower one, this lower graph. So once again, there's a relationship between the amount of caffeine and response time, x-axis, y-axis. And it looks like response time gets faster as you increase the amount of caffeine. For the no alcohol group, that change is pretty small, whereas you look at the alcohol group and their response time decreases very, very rapidly as you add caffeine. So if you look at the two slopes, the slopes are different. So the effect of caffeine on response time for the no alcohol group is pretty small, but the response time for the alcohol group based on the amount of caffeine is very, very big amount of change. So a factorial design will allow you to look at the independent effect of alcohol on response time and the independent effect of caffeine on response time, but you can also include an interaction effect where you can look at the differences between alcohol and caffeine in terms of response time. So the world is much more complex than just in an experimental setting where you manipulate one independent variable to get some outcome change in a dependent variable. There are a multitude of different potential compounding effects that would happen, and so this helps better replicate that. Let me just show you another one. In a typical scatter plot, like amount of time watching television programs and high school grade average, you could see like not the blue or the red, but imagine that all of these are black. And if they're all black, it doesn't look like there's any relationship. Like they all kind of scattered in a pretty horizontal line. And you would see that line that would look, a line of best fit would be, right here through the middle, horizontally. But if you then break apart the types of television that are watched in terms of high school GPA, it's very possible that you could have a relationship there that was not apparent without introducing educational or non-educational television. So in other words, we could see that maybe time watching television programs by itself might not be related to high school GPA. But if you break that apart into educational TV watched versus non-educational TV watched, the non-educational TV watched would be the red dots, and they would show that the increase in amount of time watching would actually lead to a lower GPA. And if you watched educational TV, focus on the blue dots, if you watched more educational TV, it actually increased your high school GPA. So in this instance, a simple bivariate correlation looking at time and GPA would show no relationship. But if you added another factor, in other words, you broke that apart into educational and non-educational television, you'll see that there are relationships, but the relationships don't look like relationships if you just look at them based on one of those categories. So it's important sometimes if we're analyzing data to look at multiple ways in which that data can be cut or divided up, because there could be relationships there. Factorial designs have an almost unlimited range of potential applications, blah, 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 blah. This is great. So why would we not do them? Well, you have to be considerate of the fact that every time you add some new treatment, you have to increase the number of individuals in each treatment in order to find statistically significant results. Because instead of having like 1,000 people in a whole sample, if you break that up into 4 different groups, now you only have 250 individuals in 4 different choices. That's just 2 factors with 2 choices. Let's say a 2x4 design has 8 treatments. You need enough participants in each one of those to have enough variation and enough difference to see that there's an actual difference statistically. Then there could be natural variation that, and there are confounds. In other words, there are other potential variables that could be in there that are creating some of these changes. And the number of factors versus the number of participants. Let's imagine that we start breaking everything apart into multiple different subcategories. Well, this person's a male, female, this person has this kind of GPA, this person has this, blah, 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 blah. We start breaking every individual up into these different categories. You'll have more categories than you have participants, and that could be a real problem. So the strength in a factorial design is to break it down into a couple key sets of relationships or key variables, and then get enough variation in your sample so that you can find whether or not those difference in a large enough sample that you can find differences in those groups. And when we do that, we end up holding a lot of things constant. So it solves the individual difference problems to constrain our sets of independent variables that we're looking at, but it also reduces generalizability. So if we're not looking at all the potential choices, we're looking at maybe 3 or 4 different categories or independent variables. We're saying, well, these things only matter. Well, that's probably not true either, but we can't increase the number of factors to replicate the world. So as we constrain the number of variables we're looking at, we minimize external generalizability, external validity, how much we can say about these things. So because of these factorial designs and all the other potential problems and strengths, a lot of social science research ends up in large N correlational research. So instead of like big experimental or quasi-experimental or factorial design types of experiments, we end up getting these large correlational studies. So correlational studies are a little bit different than other designs. In a factorial design, we might be doing this in advance, a priori. Experiments are most often designed beforehand. And correlational research often is based on post hoc data gathering and analysis. So we gather data and then we try and, after we've gathered the data, we rip it apart to see what things are correlated with each other. Why should you use correlational research? Well, a couple good reasons. One is the data is already there, so we could see if there are relationships in the data to do some preliminary understanding of what's going on. And if the data set's big enough, maybe you can find really, really strong relationships that you would go back and do computer simulations with, or you would, go and maybe do some sort of factorial design or experimental research afterwards to follow up. Correlational research is really, really strong in generalizability. We've got data out there. It's already existing. It reflects the world because it's drawn from the world. And you can get lots of big picture trends. There's consistent trends. We can look at all sorts of different types of data set to see if those relationships exist. It's already there. The other thing that's really good about correlational research is because it's based in reality, instead of some manipulated, experimental setting, then it's really good for prediction. We might not be able to understand all of the variation out there in the world that we can't explain, but if we can predict maybe 50% of the outcome based on existing data, that's pretty good. We're not really good at tweaking how precise these things are, but if we didn't know anything and now we know 50%, that's pretty amazing. So it's good for prediction and maybe what's coming next. But also correlational research can help us identify unusual cases. So if there's a trend line of things that are going on and we see one group that's doing really much better than expected or much worse than it's expected, we can go in there and see like what's going on with those, with some follow-up case studies or something. Like why are these not following these big trends? And maybe there's something interesting to study there. What you see in correlational research looks like this. You have a strong argument from the literature that literature says this is why it should exist. These are the variables that are important. You're gathering all this, literature review. These are things that should be here. And then when you go to analyze data, you'll see like graphs and scatter plots and maybe a statistical test, a simple bivariate correlation. You'll run a regression. There's some linear or other different kinds of forms of, we gathered this data, we ran these statistics, we put some output tables out. This is, these are the relationships that exist in there, and then this is what we should learn from that. So I'm going to give you a quick example from my research. During May, of the COVID pandemic. So COVID pandemic hit the U.S. more or less in March, a little bit earlier, but March is when everything started to lock down. By the time May and June rolled around, everybody was pretty concerned or worried about what government should be doing, what government shouldn't be doing. We've got local officials fighting with state officials, fighting with federal government officials about what's appropriate. We've got political parties on both sides arguing with each other. So I wanted to understand what drives support for COVID policies. Like, are there factors inside individuals that are related to that? And I had some hypotheses. And really, this response to COVID presents a set of competing problems for policymakers and the public. We need to save lives, but we need to keep the economy going. We need to preserve government legitimacy. In other words, like government should have a role in some of these things or shouldn't. And individuals' perceptions of what was going on were going to affect whether or not they supported government restrictions on some of their liberties. So we also wanted to figure out, like, were media stories influential, or were personal relationships more influential about support for these policies? And then we wanted to see who we could save from the virus. Now, if you've watched my experimental video, we did a conjoint experiment where we gave people some simulated individuals and we ran an experiment to try and see if we could tease out who they would save. That's not going to be reported here, but we'll talk about the correlational research we did at the beginning of the study. We wanted to look at why people were opposed to policies that restricted movement. We thought about like partisanship, or are you part of a specific group? What kind of information do you know? And then, there's some implicit willingness to allow one group to bear the burdens more than others. Like, do business owners bear it because we're restricting it, or should older people end up bearing the burden because we're going to open up and, put their lives at risk? These are the sort of trade-offs that people were facing. And, some states opened up completely and some states locked down for, extra 5 months. And what we've essentially done is shift the burden to different groups. So some competing theories are out there about how people perceive threat, and threat in terms of health of self, but also threat to other individuals, and how much empathy individuals have. We have this idea, though, too, that personal knowledge is going to be more powerful or influential than information you see in the media, because people maybe don't trust the media, but you might trust your friends. Now, if your friends are really scared about some sickness, or maybe they've gotten it, or maybe they're really scared about losing their business because their businesses are shut down, those things all play a role in how people understand and interpret knowledge and what knowledge is important. So we looked at infection rates and whether or not their friends were infected, or whether or not their friends had lost businesses or been economically disadvantaged. And then we wanted to see if we could simulate some sort of contact, like how much does media pressure or media stories affect people's perception of risk. And so what we did was we conducted this survey, 2,000 people between June 11th and June 18th, 2020. We used a survey sampling group called Lucid Theorem. It replicates the US population pretty well. We did an embedded experiment where we had a pre-post treatment. The first was they saw a 42-second video from ABC News about an African-American individual who had died because he went to the barber shop. Their control group was a 45-second ABC News video of a Black Lives Matter protest. And then we asked them questions about the perception of risk of the virus before. We asked them questions about who they knew, if somebody had been infected or if somebody had been economically disadvantaged. And then after this embedded experiment of showing them these two videos, we asked them the same questions, and we looked for differences in their support for government policies and their perception of risk. Then we did this conjoint experiment where we asked people who they would save. Now, if you want to watch the other video about experiments, you can read the results of that conjoint experiment. So we asked them specifically whether or not they felt concerned about someone that they know could be infected with COVID. So if somebody in their family had been infected with COVID, this is the variable, it was strongly correlated with being very concerned or somewhat concerned, and even not very concerned. So the baseline here was not at all concerned. So if you had somebody who'd been infected, then your likelihood of being more concerned was higher. Now, if that was an acquaintance, that relationship does not affect these lower influences, the not very concerned answer, but it does have an impact on whether or not they were somewhat or very concerned. So in other words, their close relationships were more powerful than these sort of affiliated relationships. Now, if they were Republican, not statistically significant relationship, but if they were Democrats, it increased their likelihood that they would perceive of COVID as risky. Age was related. Older people tended to be more very concerned or somewhat concerned than other individuals who were not as old. Gender did not seem to be related to them. Remember, these are just questions we're asking people over a survey. Income was related. Now, income was related in a really strong and similar way that it increased how concerned people were. Race only had an impact on the very, very concerned. So now that's what these things were. Now, when we started asking not about family, but about how severe a member of their family had been infected with COVID, we dropped from 2,000 individuals to just the 650 individuals who had a family member who had become infected. And we're asking them about their perception of risk. Let's see, we look for statistically significant variables. Democrats were much more very concerned, much more affected by having a family member than Republicans were. Republicans were not statistically correlated with when their family members were sick. It did not increase their likelihood of being concerned. Age, once again, positively related. So increases in age increased in concern, especially after they'd known somebody who was sick. Income, once again, was a factor. Race, in this instance, was a factor. That's to say, people of a non-minority group were much more concerned if they had had a family member who was sick with COVID than the white group of individuals who tended to be less concerned than the non-minority groups if their family members had been sick. Now, here's a really interesting finding. If people were asymptomatic, they got it, but they didn't have any really symptoms from COVID, that was statistically significant to more concerned. If their cases were very, very, very severe, then they were also increased perception of the risk. But when people died, it did not affect people's perception of the risk, which I think is really interesting. So here's one of those things where we get some correlations and we say, well, why? That doesn't make a lot of sense. Like, if we would think that if somebody died, that they would be more concerned. But maybe what's going on here, and I'm just speculating because we don't know. This is kind of what happens in correlational research. We found a relationship. If they were asymptomatic, that increased their perception of riskiness, but not if their friends had died or their family members had died. Now, why is that? Well, I don't know. Maybe they had also gotten it. That may be something we didn't measure very well or haven't controlled for in that. Maybe these respondents, their family member died and they were asymptomatic. Or maybe just the fact that people had gotten it and nobody knew about it. Maybe what's being measured here is their concern not about the risk to their individual health, like they're going to die, but it's proxying for something like how contagious COVID was, and it was surprising that people had it, but nobody had become like they become infected, but they hadn't manifest symptoms. Because they hadn't manifest symptoms, they hadn't changed their behavior, and it spread to other people. Like, this is something we don't know because we didn't ask that question in the survey, but we do find these relationships, and so we have to figure out like what's driving this perception of risk. Is it something that they don't see it as risk because they've had some previous experience, or they had the experience and then they don't perceive it as risk afterwards? In a correlational research, you can't determine causality because you don't have time order. So there's some potential problems. So, all right, then we ask them, how would they oppose certain types of policies? How strongly do you oppose stay-at-home orders, closed bars, limiting gathering, restricting travel, closing salons, closing churches? And then once again, looking at infections, whether or not their family had been affected, or whether or not it was just based on risk. Now, risk perception all across the board, whether or not people perceived of it as risky, was a primary determinant about whether or not they opposed these policies. When we start looking at the percent, like how many people they guessed were infected in their area, that also affected whether or not some of these variables had opposition, like restricting travel, closing churches, closing bars, and stay at home. We also asked them a question inside the survey about whether or not they had a family member, close family member, or an acquaintance who had suffered economic losses due to the closings. And when we look across here, perception of closing bars, they were more in favor of, they were more opposed to closing bars if they had a family member who was economically impacted. The same thing happens with closing salons. Salons generate money, bars generate money, but interesting, across the ones that don't, like staying at home, limiting gatherings, restricting travel, and closing churches, they don't see those as necessarily, actually closing churches it does, as money-making industries. So we're trying to figure out like why would some people support some things and some people support other things. Their perception of risk because of family members who've been infected, but also their perception of risk based on economic risks. Here we go. Post-materialism is an ideology score about how important things like environmentalism and public health are to other people. Liberal people tended to be less opposed. Libertarians, people who don't like general restrictions on government freedoms, they were more opposed to all of these generally. And then party identification. And then looking at these sort of different race groups and how they responded. Okay, so then we did this pre-test and post-test, before the video, after the video, and if any of these had changed, if showing the video changed whether or not they opposed things. And really very small amounts of change happen. Stay-at-home orders do see changes in support based on whether or not they were in that experiment group, and also whether or not they had an acquaintance, but also this measure called empathetic concern. Empathetic concern is this general idea, it's measured using a number of different variables, about how empathetic or sympathetic people are to hearing compassionate stories. And in that story where we show those individuals a story about somebody who died, it talked about, like, one of the last statements that she said was, "I just wish people would stay at home and then my husband wouldn't have died." And so I think that pulled on people's heartstrings in some way. But if you look across all of these, there's none of these variables, if you look horizontally across the tabs, that are consistent predictors of whether or not these particular types of closures, there's no solid, consistent, robust variable predictor that would more or less say this is what is related to these all of these different measures of restricting the economy or protections for COVID. So these are kind of sporadic, and we were left with thinking like, well, what does this actually mean? And overall, what we drew from this is that we might be seeing some changes based on the treatment, but really it only affected like closing bars and stay at home. It didn't even affect the one that's talking about closing salons. So we just said it doesn't look like these treatments really mattered. And it gave us more strength for this previous one about how people perceive risk and how people are engaged in in their relationships with other people, how that affects their risk or their knowledge of a situation. All right, so the strengths and weaknesses of correlational research. It is non-intrusive. You have lots of predictive power in terms of gathering large samples very easily. It determines consistency and strength of the relationship really well. High external validity because you're not controlling things in an artificial way. Weaknesses. Big ones. You cannot address causality because in order to address causality, you have to be able to identify specific manipulations in the independent variable that affect outcomes, controlling for external influences, reducing the impact of unobserved variables. In correlational research, we could have variables that we didn't measure out there, like third variable problems that might be driving something we just don't know anything about because we didn't measure that or we didn't have data about it. There's no directionality. In other words, we don't know if one thing caused the other thing or the other thing caused that one. We just know that they're correlated with each other. And then there's low internal validity. It's possible that our models are built so incompletely that we have missing variables all over the place. And so correlational research, large N correlational research is really good for a lot of things, but causality it's really bad at. Another way to think about a non-experimental, non-correlational design is called descriptive research, and this fits into a whole bunch of different categories, but descriptive research is about cases and not relationships between variables. It's really to describe maybe a single variable or a single set of variables independently of each other. It helps us get an understanding of like specific topics like environmental justice. We're going out there, we're looking, we're watching, we're trying to see what this looks like. We're trying to describe what's happening. We did a study on a mine, a descriptive research study looking at how roots develop in sodic soils. We had planted trees, 15 years earlier. We went down and we cut and we tried to see how they were really deep roots, how these little teeny tiny seedlings were developing their root systems. And we just described how they went and if they followed certain kind of patterns or not. We weren't doing anything correlational. We weren't like experimenting on anything. We were just trying to figure out what those things looked like. And the point was to try and get a better sense how things grow. Well, okay. What use does that? Well, it helped us understand something that we didn't understand very well before, and it helped generate ideas about, oh, well, I wonder if we tested this or we tested that because I see these patterns. Another thing, a while ago, transit-oriented development was this big deal. Build developments near transit hubs, and they're good in theory. We can do correlational research. We can do all sorts of other things, but really, if you want to see what that looks like, you might have to just go and sit and watch and look at patterns, maybe look at train schedules or bus schedules, and just kind of seep in the data and seep in these observations so that you can kind of describe what's going on. That's really what descriptive research does. Now, if you're going to do something like this and you're going to do something like observational, you need a really good, reliable, well-developed measurement scheme. In other words, you'll need to be able to not just say, well, this sort of thing happened. You'd have to say, well, these things are sort of good and these things are sort of bad, and this is how I'm going to describe this one kind of behavior. And you write out this coding scheme so that as you're describing, somebody could go back and sit there and get the same sort of information that you would be getting if you were sitting there at the same time. And we have to train people to do this as well. So if I'm gonna do observational research, you can't just rely on me because I might introduce individual bias. So what we do is we set up a coding scheme, some conceptual measurement or operational measurements that if you're out here measuring on this one day and I'm out here measuring on this one day, we could use those codes and we'll get the same sort of information back. Now, when one person who's doing observational research has a coding scheme and this other person has the same coding scheme, we can check to see if there's bias or whether or not we're observing the same thing through called inter-rater reliability checks. We check their data against this data to see if they're the same. Now, if they're gathering data and we're gathering data and we're using the same coding scheme, but we're not getting the same sort of data, whether or not those written observations or whatever that is, then we'd say we don't have inter-rater reliability. There's no rating between the people that's reliable. So we'd have to go back and recode We'd have to rewrite a measurement scheme so we can know what we're looking for. The whole idea is to minimize the influence of the single observer. So anybody could go out and do this and get the same sort of information using observational research. Now, there's all sorts of problems with observational research, like how do we measure? What are we trying to measure? It's the same in social and physical sciences. How often does something show up? How long does something show up? Is there a time frame? Does it happen in a sort of pattern? Do we measure percentages? Do we measure counts? All these sorts of things are part of observational research that we need to figure out what they are. I remember sitting in a ecology class as an undergraduate, and we went out to measure vegetation, and we wrote down percentages of species. So we had the species name and then a percentage inside that frame we estimated. But the problem was they didn't want percentages of cover. They didn't tell us that. They just wanted to count how many of these things there were. Well, by the time I had percentages, we had just measured the wrong thing and we failed the lab. And I thought, well, that's stupid. You should have told us you wanted to count instead of a percentage cover. Because they didn't tell us, we gathered the wrong data. Then we have to figure out units of time. Like how often are we sampling? Are we sampling individual events? Are we sampling a time frame? Are we sampling individuals or groups of individuals? Or how often a group of individuals does a certain thing? All that stuff has to be really clear in observational research so that we know what information we're gathering and what we can use that for. So there's some non-intrusive ways and there's some really intrusive ways that we can do observational research. Non-intrusive is like content analysis. We go into previous information, previous databases, archives. We gather data that's already been collected, or maybe we're gathering raw information from, presidential letters are a great way to do that. Memos. If we're trying to figure out how the bureaucracy works, we might go back and grab staff memos. You might go grab journals from great scientists and see how often they recorded observations, right? That's all non-intrusive content analysis or archival research. Something that's semi-intrusive would be something like survey research or a contrived observation. A contrived observation would be like where you're trying really hard to hide in your observation what's going on. Survey research is easy. We're asking people questions. It really doesn't hurt their doesn't mess up their day. Doesn't take a lot of time, but it does. They do know that they're being observed. Now, a really intrusive observational research would be like naturalistic observation. You go and sit in a plot and you're watching what's going on. Well, just the nature of you being there changes what's going to happen with the wildlife. Like how long do you have to sit before the birds come back? How quiet do you have to be before the animals come? Sometimes the animals will smell you and they'll never come back, right? So we've disturbed the natural environment in such a way that it's no longer natural, but we need to be in it in order to observe it. This is one of those intrusive observational research designs. Another thing is like participant observation. We talked about Laud Humphreys. He was a participant observer inside a research study. He participated in what was going on, and because he was there, he changed the dynamic of the observation. So, you just have to think through, like some things you have to do observational research for to get a sense of what's going on, but each one of these things is going to have some strengths and weaknesses. Like, can you do some sort of contrived observation where you're observing, but they don't think you're observing for another reason? Can you hide yourself inside the environment? I mean, there's a lot of different things that we might tweak to try and get better data. Just a side note about surveys. Surveys are really problematic for a lot of reasons because participants will respond even if they know nothing. They might tell you what they think you want to know. There's all sorts of potential problems. They might just want to get it done quickly and just say the first answer all the time. It's called mainlining. But also, survey questions have to be designed in such a way that they're going to measure the thing that you really want them to measure. And that's not always easy. So you have to get some, feedback from other people about, whether or not your question is measuring what you want it to measure. And then you have to ask questions about sampling. Did you get a representative sample? Did people not show up in your survey data because of non-response bias? Are they not answering certain questions, not out of randomness, but because they're awkward questions or they don't want to give you that information? Like most of the time, if you ask a religious preference on a survey, you ask people's individual ages, really personal questions about, their sexual behavior, they're just not going to answer. Well, maybe they're not answering for a real reason that you really want to know, but you don't know. But the survey data won't tell you because they didn't answer the question. And there might be a pattern of bias in that non-response because maybe they feel like there's social pressure to answer a certain way or not a certain way. Then there's questions about open-ended versus restricted choice versus rating scales. Every one of these things the design of the question is going to give you different kind of information, and what you can do with that information is different based on what kind of things you do. Telephone surveys, paper surveys, internet or email surveys, individual interviews or surveys, and they all have different potential problems about how intrusive they are, what kinds of questions you can ask. There's all sorts of potential problems. And then interviewer bias and wording bias. So if an interviewer is listening, are they hearing what the words are that are coming out of that person's mouth, and do they have the same contextual understanding of what that means? Are there key words that we're missing culturally because the interviewer and the interviewee come from different backgrounds or experiences? How they word things might be different than the way that we understand what that wording means. So all these potential problems in observational research have to be minimized early on in your coding scheme. And you have to be able to train people to look for potential problems. And surveys are a measurement strategy, but people often confuse them for research design because they're a type of observational strategy that's also pinned with a measurement strategy. But primarily, surveys are a measurement strategy that matches up with a non-intrusive or a semi-intrusive research design, observational research design. Sorry. Everybody says, well, what about case studies? What are case studies? Case studies are observational research, or they can be archival kind of research. They're kind of single study designs, but they are misused all of the time. They're misused because people don't understand why. People want to write case studies because they want to tell a great story. Okay, great. That is good, but it's really good. Case studies are really good at describing the exception to the rule to discredit a theory. They have zero internal validity and they have zero external validity because you can't make a prediction from a case study. There's one observation and there's one unit of analysis. That's the N is 1, and yet you have 50 different variables that are all going on at the same time. And if you want to draw a line to make a prediction, you need 2 data points. A case study is 1 data point. They're good at lots of description. They're good at thinking through things. They're good at observation. They're good at oh man, we should think about this and this and this and this, maybe to generate ideas for theory. They are not good for testing theory. They're really, really good for discrediting a theory. So imagine I did a case study that was correlational research on individuals who lived very, very close to a hazardous waste site. And what I said was the environmental justice literature has some stuff that's wrong with it because it assumes that white people and that rich people will stand up and fight against hazardous waste sites in their area. Well, I found a case where there were rich white people living next to a hazardous waste facility, and there was some environmental remediation stuff that was going on during that time. Not anybody really protested. The only people who protested were close enough that they could see the site from their house. And in minority communities or in white communities, that's about the same pattern. So the environmental justice literature had argued at that point that it was because they're racial minorities. They don't have time to go out and protest. They don't have access to all these other things, but rich white people do. Well, I found a case where there were rich white people living next to a hazardous waste facility, and they behaved in the same way as the poor minority communities when it came to engaging at hazardous waste facilities. So, I mean, that's a case where you say, oh my gosh, all these big patterns trend towards this in the literature. And I was like, well, okay, well, I know about this case over here, and it doesn't. So, all right, so the problem with case studies, once again, you can't build theory, you can't test theory. What you can say is there is something out here that doesn't conform to the theory, and you can start generating lots of information about it and telling a good story. Once again, no internal validity, no external validity. It's full of bias. You selected a case. It wasn't random. You have to interpret that data in context of what you know, how you see the world around you, just chock full of bias. It's just full of bias. But we use case studies all the time, but they're used wrong. So they do have a purpose, but the purpose is not to generate new theory or to prove some theory. It's really to show that there are exceptions to a theory and to provide lots of rich data that might be used in the future for future studies that can be conducted in a more systematic way with less bias. Okay, case study is a single subject design, but it's a particularly bad kind. But a single subject design could be also something like trying to see if a certain type of thing impacts an individual. They're really designed for cause and effect, where we really, really control them like an experiment. One of the best ones that I can think of is like where the treatment might cause death to an individual. And so because the risk is so high, you don't want to do that for everybody. So you choose like one or two individuals to treat or to test something on. And then that individual assumes that risk and you see if that happens. Also, a single subject design could be something like the treatment has to be individually tailored to a patient and is very costly. And this is the most amazing thing. A while back, they created a cure for a guy who had contracted HIV, and they used some stem cells and some other genetic material, and they cured this guy of HIV. And I mean, it's like miraculous. And you can link to it in the PowerPoint. You can Google it. But essentially, they said, we're going to spend a ton of money to see if this thing's going to work, and it did. But then, in order to like test it again on somebody else, they have to create that treatment individually, specifically for that next individual. And so they're looking at these relationships. They're looking at, can this thing actually happen? Yes. Well, then it's like the first step at understanding a process, but it's so increasingly difficult to do and restrictive and resource intensive that they can really limit it to one person. They can really limit it to one independent variable. Like, has to be really, really constrained. Now, once again, this is a case study. It's showing that treatment caused an outcome with only one case. You can't draw a line with 1 point. You have to have 2 points. There's no statistical testing. It's just like, look, it's proof of concept. It worked. Well, if you're building, if you're an entrepreneur and you're building like one thing that works, that's pretty cool. But then you got to figure out how you can build that thing multiple times and whether or not it's going to be reliable, right? Single subject designs is like the proof of concept. I've figured out how it could work in a lab under these conditions. Yay! And then you use that data to like build something bigger. And then there's like, in these single subject designs, there are lots of ethical concerns about forcing a patient back to the base condition by withdrawing some treatment. We talked about that in experimental designs. We give them a treatment, then we remove the treatment to see if the treatment is going to be permanent or not permanent. You wouldn't want to give somebody a drug that like cures them of HIV and then you remove the drug to see if it really was a cure. You'd want to just keep giving them that drug to make sure that it continued to work. So lots of problems with single subject designs, but they can be very, very helpful. Okay, we've talked about all sorts of things: experimental, non-experimental, quasi, correlational, descriptive, observational. Think about how they all work together. What is their purpose? How do you set them up? What are their strengths? What are their weaknesses? And then could you tell me what differentiates them?